Hello and welcome to this video presentation titled Model Selection Bias in Current QCA Software, Problems of FSQCA and Tosmana. The motivation for this video is a paper that I have actually already published in 2013, which first showed that FSQCA, the software by Charles Regan and Sean Davey, and Tosmana, the computer program by Lasse Kronqvist, concealed some explanatory models from their users. That is, these two programs only showed a subset of all the models that fit the data equally well to the user. Now, model concealment obviously leads to stronger inferences from the data than are actually warranted, and that in turn leads to an overselling of research findings. And depending on the number of models that are concealed from the users, this overselling can be considerable. Further research has been carried out in Team 2013, an article that was published in the Evaluation Review, and a much more detailed article that I have co-authored with Michael Baumgartner, and that was published in 2015 in Sociological Methods and Research. These two articles analyzed the problem in more detail. But given that this problem has been known for a couple of years, I still find it very surprising that many beginning users of QCA are still not informed in the courses that they attend about this problem of model selection bias. What I'm going to demonstrate in this video presentation is that the serious problem still persists in the most recent versions of FSQCA and Tosmana. Here are the references that I've just mentioned for your information in case you want to have a closer look, particularly at the articles that I've spoken about. But now let's come to practical issues and use real data. For comparison purposes, I use my QCA Pro package, which is guaranteed to present all data fitting models to the user. Now I first load this program, and the first thing we do now is to load a simple data set. I call it data 1, that you see here. There's nothing peculiar about this. There's 4 exogenous factors. It's got 15 cases because case number 10 is missing, but the rows here, the labels are just the names of the cases. So they are not 16 cases, they're just 15 cases because case number 10 is missing. Nothing idiosyncratic about this data. Well, there's not much limited diversity, obviously, but it's just like any data set. And let's analyze this data set now with QCA Pro. As I said, the software is guaranteed to produce an objective solution, meaning that this solution will comprise all data fitting models. As you see, there's one model, A or not B or not C, and D is minimally necessary and sufficient for O. Now let's see what FSQCA is doing with these data. And in case you know FSQCA, most applied researchers first experiment with this software, so I guess there's no need to explain all the details here about what I'm doing here now. I select what's called causal conditions in FSQCA. I set the outcome. You may also want to add the cases in the output. I use automatic coding here just because it's a little quicker. And now I specify the analysis. I produce the parsimonious solution here and click OK. Now you're presented with, as you see here, I just enlarge it a little bit because the font size is very small in FSQCA. By the way, this is the latest version of FSQCA, version 3. Now you see it reproduces the solution in exactly the same way as QCA Pro. There's one model, not B or A or not C and D. Let's check what Tosmana is doing, and we shouldn't expect the software to produce any solution that is different from what we've just seen in QCA Pro and FSQCA. Again, I produce the parsimonious solution, do a full analysis, and you see that the solution contains exactly the same models. Okay, so far so good. No problems, it seems. Now let's modify these data a little. I load a new data set that is exactly the same. The cases and the labels that they carry are exactly the same. The only difference now in data set and data 2 is that cases 8, 9 and 13 are missing. So we've got 3 cases missing, a little bit more, limited diversity. Again, nothing spectacular about these data, small data set, not very many exogenous factors. Okay, let's start with FSQCA first. Let's first load these data into the software. Okay, and redo the steps that we've just carried out. Click OK. Let's code the outcome. Specify the analysis to produce only the parsimonious solution. And you're presented with a solution that contains a single model. Namely, a model consisting of not A and not B, or A and C, or B and D. Okay. Let's go to Tosmana. Open the data set called data 2 and analyze it in the same way as we've just done. Explain outcome 1 and include remainders for reduction. Now, as you see here, Tosmana produces exactly the same solution as FSQCA, namely a single model that makes up the solution not A and not B, or A and C, or B and D. Again here for confirmation. What's problematic about this solution is that it conceals a vast amount of models that fit these data equally well. Namely 13 other models. The model you're presented with by Tosmana and FSQCA is only this one here. However, this is only one out of 14 possible models that fit these data. Now you already see that FSQCA and Tosmana have a preference, an inbuilt selection bias that works in favor of those models that have the smallest number of prime implicants. Now, given that QCA and the approach around it emphasize causal complexity and the fact that different paths and different numbers of paths can lead to one the same outcome, this is very surprising that these two programs conceal all models that do not have a minimal number of causal paths to the outcome. However, all these 14 models are indistinguishable. They are all minimally necessary disjunctions of minimally sufficient conditions for the outcome. And it could well be that model number 14 was the true story behind the data in the data set called data 2, not this one. So what you would expect as a researcher is to be presented with all models that fit the analyzed data equally well. By being presented only with this model, you're led to believe that the causal story behind your data is much cleaner and much clearer than it actually is. But this is not where it stops, unfortunately. Let's load a third data set called data 3 first into FSQCA. Again, some limited diversity. We've got cases 1, 2, 5, 8, and 11 and 14 missing. So a little bit more limited diversity, but not too serious so far. I mean, with 4 exogenous factors and 10 cases left, that could still be a very plausible and realistic QCA study. Now let's analyze these data. Again, first with this QCA. I again code the outcome automatically here to save some time. Produce the parsimony solution. Now, what you're presented with now here is called a prime implicant chart. Now, this is not the full chart, but usually FSQCA only presents to you the part of the chart where ambiguities occur or where prime implicants are tied. So reading the FSQCA manual, it says that you should pick those prime implicants here that you think are in line with theory. Now, first of all, this is obviously already a selection bias, a confirmation bias that you introduce manually. Now, probably, well, you might pick the first 2 here, and then maybe the last 2. Still need that one to build your solution. Okay, here's the solution. Not B and not D, or A and not D, or B and D, or C and D. Okay, so far so good. Let's go to Tosmana. Load exactly the same data set. Let's analyze this data set. Include outcome 1, explain outcome 1, and include remainers for reduction. Now, the first surprising thing you find is that the solution now is not the same as the one produced by FSQCA. Well, now this is no surprise, since you are presented with a prime implicant chart where you could automatically pick your prime implicants manually. This is already a first problem. So for the same set of data, users using different software will produce very different solutions. But this is not all there is about the problem of model selection bias. Tosmana presents you with a single model in its solution. Now, obviously, in FSQCA, you had the option of choosing different prime implicants, and this was just one choice here. However, Tosmana conceals from you that, in fact, for the data in the dataset data 3, there are no fewer than 57 different models fitting these data equally well. Tosmana will present you with only a single model, concealing all the 56 other models. Now again, this is a case of being presented with evidence that leads to a massive overselling of research findings. It's unclear which of these models is the true causal story behind the data in data 3. It could be any single one of these 57, not necessarily the first one. FSQCA, in contrast to Tosmana, however, has an additional problem. Whereas Tosmana has this inbuilt automatic routine, this preference for only those models that contain the fewest numbers of causal paths, FSQCA even conceals some prime implicants from the user and doesn't use these prime implicants in its model building process. To see this, let's rerun the analyses very briefly here. Okay, let's specify the parsimonious solution. Now, obviously, you see here that we've got 3, 4, 5, 6, 7, 8, 9 alternative causal paths listed here, so-called prime implicants, 9. However, they're not just 9. In fact, there are 4, 6, 8, 10, 12 prime implicants. FSQCA thus not just conceals models from you, but it also drops some possible causal paths from the entire analyses. And in this case, it's not A and not B, for example, is not contained in the list of prime implicants, nor is not A and not C. You don't find this prime implicant here. And also not C and not D is not contained in the list of prime implicants, even though clearly these 3 prime implicants are minimally sufficient conditions for the outcome, which you can easily see when you call up the data. So not A and not B is consistently associated with a positive outcome. Drop any one of these, either not A, then you're left with not B, but not B is associated also with the negation of the outcome. The same for not A. Not A alone is associated also with the negation of the outcome. So not A, not B clearly is a minimally sufficient condition and should show up in the prime implicant chart. Now, what the bottom line of this is, of all this is that an objective analysis of social scientific data or whatever data is not possible with FSQCA and Tosmana, at least currently, and that has been the case for probably the last 20 years, at least with respect to FSQCA, and the last 10 years with respect to Tosmana. So these two programs clearly have an inbuilt model selection bias that leads to much clearer findings in analyzing data than are really warranted. If you want to carry out an objective analysis of your data, the only program that currently produces all data fitting models in an objective way using standard settings is the QCA Pro package for R. And this is a very serious, from my perspective, this is one of the most serious issues in QCA, considering that about 1,000 QCA publications have now appeared as journal articles and books, and well, about 90% of them used the FSQCA software. And meaning that about 90% of all published QCA studies of the last 25 years have run the risk of massively overselling the evidence that was contained in their data.